today let's continue with the preliminary 7, which was the trigonometric functions. Okay. And this is our right triangle, and this is the T angle. We will call this side opposite side because of it's the opposite of the T angle. Okay, and the adjacent, this side will be adjacent, and this long side will be, as you know, hypotenuse. Okay, and the cosine t equals to adjacent side over hypotenuse side, and the sine t equals to opposite side over hypotenuse, and the, you know that I know, and the definition the radian measure of angle AO PT is T radians, okay, and the AOPT equals to T radians. Let me sketch it on the unit circle and you will understand it clearly. Okay, and it's unit circle, and this is point P sub T, okay, and this is T angle. Of course, this point is origin, and this point must be A, and the A is, you know, if it is unit circle, A must be 1, 0 point, and this point is P sub pi over 2, and this point is P sub pi, and this point is P sub minus pi over 2, and we can say about this P sub T point, it equals to, okay, and the cosine T and the sine T, because of when you take this point's projection on the x-axis and the y-axis, okay, you will obtain these sides, okay, you can see them clearly, okay, and this part is sine t, and this part will be cosine t, because of hypotenuse equals to 1, its measure equals to 1, okay, so we can say this is sine t and this is cosine t, okay, and our measurement value will be radians, okay. okay? And we are, let me write it, we are more used to measuring angles in degrees, okay? Since p sub pi is the point -1, 0, halfway around and this is the C, and the unit circle's equation will be, of course, x squared plus y squared equals to 1 around C from A, and we have pi radians equals to 180 degrees. And let me define useful trigonometric functions which are sine and cosine function. You know that cosine and sine functions, and we can say for any real t angles, cosine t equals to the x coordinate of p sub t point, as you see above, and the sine t equals to the y coordinate of p sub t points. And then let me give you some useful identities. Okay, maybe you can see lots of them at the page 46. Okay. And what can we say about this trigonometric functions? The range of cosine and sine -1 less than or equal to cosine t less than or equal to +1, and the same range will be equal for sine t, and the Pythagorean or Ömer-Hayyam identity cos square t plus sin square t equals to 1, and the periodicity, we can say cosine t plus 2 pi equals to cosine t, and the sine t plus pi equals to sine t, and the cosine is an even function. This is important. And the sine is an odd function. Okay, and what does it mean? Please remember even and odd functions from the previous lecture, and the cosine minus t equals to cosine t because of its even function, and the sine minus t equals to minus sine t. Okay, don't forget it. And the another property about these functions, complementary angle identities. What's that? Cosine of pi over 2 minus t, it equals to sine t. It's complementary function. By the meaning of pi over 2 is sine t, and similarly you can say sine pi over t minus, sine pi over 2 minus t equals to cosine t, and the supplementary angle identities. It will be around the pi angle, and so cosine pi minus t equals to minus cosine t, and the sine pi minus t equals to, yes, sine t. Okay, and then let me give you some example about this complementary angles. Okay, find cosine 2 pi over 3 and sine 5 pi over 4 angles. Okay, and the okay, let's think our unit circle which measurement is 1. Okay, and this angle is 2 pi over 3. Okay, from the supplementary property, here will be pi over 3, and from the supplementary angle identity you can write it cosine, okay, 2 pi over 3 equals to cosine pi minus pi over 3, right? And it's equal to minus cosine pi over 3, and we know that cosine pi over 3 equals to 1 over 2, so it's equal to minus 1 over 2. Okay, and the second one, please remember again the unit circle and this measurement will be 1, and the first green angle will be 5 pi over 4. Okay, and the second one will be pi over 4 angle. So what can we say about this? Sine 5 pi over 4 equals to sine pi plus pi over 4, of course, and it's equal to minus 1 over 2. I'm sorry, it's not 1 over 2. Minus square root of 2 over 2. Okay. And then let me sketch the sine and cosine functions. And the next page. Let me sketch first the cosine function. Yep. And this point is plus 1. And this is minus 1. This point is pi over 2, and this is pi, and this point is minus pi over 2, and this point is minus pi. Okay, and the cosine function will be like that. Okay, this is the y equals to cosine x. Okay, and as you see, it's an even function which is symmetric around the y-axis. Okay, and again, let me sketch the similarly sine function. Okay, and what can we say about it? It will be it's an odd function. Okay, and it's equal to sine of x. Okay, and let me write some addition formulas for cosine and sine. cosine s plus or minus t equals to cosine s and cosine t, okay, minus or plus, okay. The sign position will be changed and the sign position will be changed, and the sine s sine t, and the other formula sine s plus or minus t, and the position will not change, and the sine s cosine t plus or minus cosine s sine t. Okay, and the example, find the value of sine 5 pi over 12, which is equal to sine 75 degrees. Okay, what can we do about it? We can do sine 5 pi over 12, it equals to sine pi over 4 plus pi over 6, okay, and it equals to, from the formulas, okay, sine pi over 4 times cosine pi over 6 plus cosine pi over 4 times sine pi over 6. So it equals to square root of 2 over 2 times square root of 3 over 2 plus square root of 2 over 2 times 1 over 2. So it equals to square root of 6 plus square root of 2 over 4. Okay. And let me write the double angle formulas. Put s equals to t into the previous formulas, which are these, okay, and you will obtain from the sine equation sine, okay, 2t, when you put, okay, t here, and it will be sine t plus t, and it equals to sine 2t, okay, and the sine 2t equals to 2 sine t cosine t, and when you put again into the cosine formula, you will obtain cosine 2t equals to cosine square t minus sine square t, or if you know sine square t plus cosine square t equals to 1, it was the Ömer Hayyam equation, as you know, from the previous page, and you can put cosine square t value and you will obtain 1 minus 2 sine square t, or you will obtain 2 cosine square t minus 1. Okay, and from this side you can obtain sine square t equals to 1 minus 2 cosine 2t over 2, and from here you can obtain again cosine square t equals to, okay, and the cosine 2t minus, plus 1, okay, over, sorry, 2. We must clear this 2, okay, and the minus only cosine, okay. And let me write other trigonometric functions. Tangent, short form tan, and the cotangent, short form which is cot, and the secant, which is sec, and the cosecant, which is the CSC. Okay, and we know that tangent t equals to sine t over cosine t. Okay, and the cot t equals to cosine t over sine t, or we can call it by the 1 over tan t, and the secant t equals to 1 over cosine t, and the cosecant t equals to 1 over sine t, right? And the example, find the cosine and cotangent of the angle theta in the range of pi over 2 comma pi, for which we have, this is important, sine theta equals to 1 over 4. It is given. So we know that sine square theta plus cosine square theta equals to 1. Ömer Hayyam's inequality. So from here you can say cosine square, okay, theta equals to 3 over 4, and this part will be here, okay, and the sine theta, okay, and the from here cosine theta equals to minus or plus square root of 3 over 2, okay, and if theta is in the range pi over 2 comma pi, so cosine theta must be equal to minus square root of 3 over 2, because of cosine theta here will be minus, okay, and the cotangent theta equals to, we know, cosine theta over sine theta, and which is minus square root of 3 over 2 over 1 over 2, okay, and it's equal to minus square root of 3 over 1, so it's equal to minus square root of 3.